Okay, geometry students, let's go ahead and start reviewing for our exam. Here we go. On your exam, you should be able to write vector AB as an ordered pair, okay? Now here, I'm telling you vector A has an initial point of -1,5 and a terminal point of 6,3. Now, taking a vector and writing it as an ordered pair, or in pre-cal we call that component form. You do not need to know that, okay? Just putting it up here. In order to do this, it's a very simple procedure and a very simple formula. You simply do this, students. You simply take your terminal point, whatever it is, and you subtract from it your initial point. It is that easy, okay? So your terminal point is 6, 3. There's your terminal point minus, here's your initial point, -1,5. So this is going to be very easy to do. And remember, when you're writing a vector as an ordered pair, you put the ordered pair in these arrow-shaped symbols, okay? 6 minus a -1 would be 7. 3 minus 5 is -2. And it's that easy, students, okay? So you just took this vector that was written with an initial point and a terminal point, and you wrote it as an ordered pair. Make sure you know how to do that. Pretty simple, but you gotta know how to do it. Okay, moving on. Now, here's vector V. Here's vector U. We are going to add two vectors, and then we're going to take what we call the dot product of two vectors. So here we go. Adding these two vectors will be very, very simple. Here's vector V and vector U. You add them. So -1 plus -6 would give you a -7. And how do I know to add them? Because of this sign right here. I'm adding the two vectors. Then I'll take this number here and this number here, add them together, and I will get 2. So there we go. You just added vectors V and U together. Pretty simple, okay? Now, let's talk about the dot product of two vectors, okay? The dot product. First of all, you would think that if you're multiplying two vectors together, you would get out another vector like this, and you don't. So please make note of that. You get out simply a number for your answer, just a number. Okay, now here is how you do this. What you do is you multiply this number here and this number here. So you multiply your first numbers together. In this case, you would get a +6. Then you multiply this number and this number together. So 5 times -3 is -15. And then in your head or with a calculator, you add these two numbers together. So a +6 plus a -15 would be a -9. And you might say, well, Mr. Earhart, do you always add those two numbers together? Yes, you always do. So when you're adding or subtracting vectors, you will get out a vector. When you're multiplying two vectors together, or it's called taking the dot product of two vectors, you will not get out a vector. You will get out a number. Okay, all right, moving on. Now, students, I know you might not be able to draw this figure very well, so this might be one of those problems where you just want to kind of watch. Okay, I'll leave that up to you. But you really need to understand what you're doing here, okay? I could very well give you a problem like this on the semester exam, okay? So here we go. Name a segment parallel to EJ. Well, students, look, here's EJ right here. A segment parallel to that would be DC. But FH would also be parallel to that. And so would GK. And you might say, well, Mr. Earhart, GK and EJ are not in the same plane. Well, I could draw them in the same plane. I could have like a piece of wood here that's slanted, going up and down inside this box, okay? So that doesn't matter. It's totally fine, okay? So there we go. Any of those three segments would be parallel to EJ, okay? Either, hold on one second, either FH or GK or DC, all of those are parallel to EJ. Okay, the next one, put a check mark here. Name a segment perpendicular to GQ. Well, here's GQ, GK right here. So segments perpendicular. Well, there's quite a few of those guys. I mean, GD would be perpendicular. There's a 90-degree angle here. KC would be perpendicular to GK. How about this side here going up and down? FG would be perpendicular to GK, definitely. How about this side here? HK would definitely be perpendicular to GK. Okay, so any of those segments would be fine. Okay, I'm going to pause if I'm going too fast. Let me just have your supervising teacher pause the video, okay? If we're going too fast, okay? Moving on to the next one. Name a segment that is skew to GD. Now, here's GD right here. Skew means it's not intersecting, but it's not in the same plane. And there's actually not quite a few of those, but there's plenty. I mean, I'm not going to try and name them all, but let's see. This line here, HK, would be an example of a line that's going to go up and down. It will never intersect this line, GD, but it's also not in the same plane, okay? JC would be an example. FH would be an example. Okay, they're never going to be in the same plane, and they're not going to intersect. Okay, EJ, and there's others too. I'm just going to stop here, but EJ here, this line here is not going to intersect GD, and they don't lie in the same plane. Remember, two lines are skew if they never intersect and do not lie in the same plane. Okay, all right, moving on to the next one here. I guess I forgot my check marks, didn't I? Keep moving on to this one here. Name a segment oblique to EJ. Now, students, when we talk about oblique lines, please listen to me very carefully. Oblique lines they do intersect. Okay? However, they are not perpendicular. Okay? And they're not parallel either, obviously, because they do intersect. So, skew lines would not be oblique lines because skew lines do not intersect, okay? So, we're looking for lines that intersect EJ but are not perpendicular. So let's find EJ first of all here. Here's EJ right here. Now, notice BE. BE is intersecting EJ right here, and there's no way they're perpendicular. Also, BJ is intersecting EJ, okay? And there's no way they're perpendicular. So I could say either BE or BJ is oblique to line EJ. Alright, now let's name a plane that is perpendicular to plane FH. So, or to line FH. So here's line FH. Let's name some planes that are perpendicular. Well, this plane right here is perpendicular. Okay, so we call that plane FHJE. Or this plane here is perpendicular. Right here. To FH, alright? So we call that plane FGKH. Now, student, here's a couple you might not have seen, but think about it, guys. This plane right here is definitely perpendicular to this line right here. There's a right angle right there, definitely. And also, this plane back here you might not have thought of, HKCJ, right here. That's also going to form a right angle with line FH right here. Okay, and so that's another plane that's perpendicular to line FH. Now name a plane that is parallel to this plane right over here. Of course, they're going to be parallel. They're going to run the same direction, but they will never intersect, okay? So plane EDCJ, or however you want to say it, would be parallel to this plane over here. Okay? Alright, let's continue on. Now, solve this using either the substitution method or the linear combination method, okay? Well, let's start off first of all with the substitution method, okay? Please take some really good notes. The substitution method, okay? You're going to look for a variable that has no number in front of it, this one, and you're going to get that variable all by itself. So bring the 3y over, make it a negative 3y. So x equals 7 minus 3y. Now that you know what x equals, take this phrase right here, which equals x, and put it in for x right up here in the other equation. So 2 times 7 minus 3y minus 5y equals negative 19. Now let's go ahead and simplify. Take your 2 and multiply it through. 14 minus 6y minus 5y equals negative 19. Combine these two together. 14 minus 11y equals negative 19. Bring the 14 over, make it a negative 14, and we get negative 11y equals negative 33. Divide both sides by a negative 11, and y equals 3. So we're halfway there. Now, pick up your 3 and put it in for y right here, and you would have x equals 7 minus 3 times 3. 7 minus 9, which is negative 2. Okay, I'm going to pause and let you get caught up there, but that would be the substitution method. The substitution method. Okay, continuing on now, the linear combination method. Here we go. Now, what you want to do is you want to get rid of your x's or y's, depending on which one would be the easier to get rid of. Okay? Now, here's what you're going to do. Remember, if we're going to get rid of our x's, then I wish I had a negative 2 right here, because I could add these two equations together, and my x's would cancel out. Okay? So, I am going to multiply this bottom equation by a negative 2. So, negative 2 times this bottom equation, negative 2 times x, negative 2x, negative 2 times 3, negative 6y, negative 2 times 7, negative 14. Let's go ahead and add these together. These will cancel. Negative 5, negative 6 is negative 11y equals negative 33. Divide both sides by a negative 11, and y equals 3. Now, students, listen. You can put 3 in for y in any of these equations or any of these. I'm going to do it up here because I have room to work. So x plus 3 times 3 equals 7. X plus 9 equals 7. X equals, bring the 9 over, make it a negative 9. It'd be negative 2. So your answer would be negative 2, comma 3. Now on your test, you may use whatever method you like the best, whether it be elimination or substitution. Okay? Alright, moving on. Write a linear equation for a line that is parallel to this line and passes through negative 4, 2. Okay? Well, here we go, guys. Remember, anytime you're writing a linear equation, you need a point, you need the slope, and you need this formula right here. Now, do we have a point? Yes, we do. Negative 4, 2, we know the line passes through that point. Now look what else else we know? We do know the slope because the linear equation that we're going to write is parallel to this line here. Remember, parallel lines have the same slope, so y is all by itself. So the slope is the number next to x, which is 2. So for this equation here, m equals 2. Well, the line I'm looking for is parallel to that line, so I know my slope will also be 2. And now you're ready for this formula here. To find b, you have to find b. So here we go. Where the y is, I'm going to put 2. Where the m is, I'm going to put a 2. Where the x is here, I'll put a -4. And then plus b. Alright, 2 times -4 is -8. Bring the 8 over, make a +8. That's 10 equals b. Okay, so now I know what the slope is. Now I know what b is. Then my final answer will be y equals 2x plus 10. Okay, there we go. So this equation here is a linear equation of a line that is parallel to this line up here. Okay, all right, moving on. Okay, now let's kind of go a different direction here. Same type of problem, but just a little different, guys. Now we're going to write a linear equation for a line that is perpendicular to a given line, okay? So anytime you're asked to write a linear equation, you need a point, you need a slope, and you need the formula right here. Now, do we have a point? Yes, we do. We know the line that we're looking for passes through this point here. Now, slope. Well, look, guys, we know that perpendicular lines have opposite reciprocal slopes. So the line that I'm trying to write an equation of is perpendicular to this line. Now, notice this equation here has y all by itself, so the number next to x is my slope. So for this linear equation here, my slope is -1/3. So if I change the sign of that and make it positive, and if I flip 1/3, I get 3, I will have the slope of this line here. Because listen, the line I'm looking for is perpendicular to this line here. And what do we know about perpendicular line slopes? They're opposite reciprocals of each other. So I have a point, I have the slope, I'm ready for my formula. This is my m, this is my x, this is my y, and so here we go. Where the y is, I will put a 2. Where the m is, I will put a 3. Where the x is, I will put a -4, and then positive b. 3 times -4 is -12. Now bring the -12 over, make it a +12. 14 equals b. So we know what the slope is. We know what b is. So we're ready to write our linear equation. Y equals 3x plus 14. There we go. Okay, alright. So we wrote a linear equation that was perpendicular to this equation here. Okay, moving on. Now here, guys, I just want to be very clear with you that you need to know what these different angles are, okay? When you have two lines cut by a transversal. So, real quick, I'd like you to write this down, okay? You need to be familiar with this. Like, you need to know that the corresponding angles would be, they come in pairs of 2, okay? Let me slide this. Oh, that's not what I want to do. All right, let me do this. There. Okay. Your corresponding angles would be 1 and 3, 2 and 4, 7 and 5, 8 and 6. So 1 and 3 are corresponding, 2 and 4 are corresponding, 7 and 5 are corresponding, 8 and 6 are corresponding, okay? Now let's list out the alternate interior angles. Well, that would be 2 and 5, and 3 and 8. So 2 and 5, and 3 and 8. Okay, so those are alternate interior angles. You need to be able to recognize these on your test. All right, how about alternate exterior angles? exterior angles. Again, if I'm going too fast, it's no big deal. Just have the supervising teacher pause the video. Let me say this right now, guys. If we do not finish this video in class today, you need to finish it over the weekend. In fact, that's your homework. You are to finish this over the weekend if we do not finish it in class today, okay? Alright, you are to finish this over the weekend. Okay, alternate exterior angles. Well, that would be 1 and 6 and 7 and 4. 1 and 6, 4 and 7. So 1 and 6, 7 and 4. Okay, and then lastly, consecutive interior angles. Consecutive interior angles. Okay, and that would be 2 and 3. And 8 and 5. So make sure, students, you're really familiar with these angles, what they mean, and where they're found on a diagram like this, okay? Alright, moving on. Now, I do want you to be able to name the 6 ways to prove that 2 lines are parallel. So here's one of those listing questions that you need to be familiar with. Now, I'm going to admit, I'm going to put these up here very quickly, okay? But you can pause the video at the end and copy all 6 down, okay? So when all 6 are up here, if you're still taking notes, just pause the video. We learned 6 ways to prove that 2 lines are parallel, okay? If their corresponding angles are congruent, or if their alternate interior angles are congruent, or if their alternate exterior angles are congruent, or consecutive interior angles are supplementary, okay? Or here's another way. If 2 lines are parallel to the same line, then those 2 lines are parallel. Or if 2 lines are perpendicular to the same line, then they are parallel. Those 2 lines are parallel. Okay, so I'm going to go ahead and move on. Go ahead and pause the video if you need to. Nothing wrong with that. And remember, if I tell you a listing question is going to be on the test, more than likely it's going to be on there. And this is a fair game question here for your test, listing out the 6 ways to prove that 2 lines are parallel. Okay, alright, moving on. Now, students, you need to be familiar with these terms. I already told you there'll be no fill in the blanks on the test. However, you need to know these because I might give you a problem saying something about an isosceles triangle or a scalene or an obtuse or a right. You need to know what these mean, okay? Again, you don't have to memorize them, but be familiar with them, okay? Alright, equilateral triangle. Excuse me for yawning, sorry. Equilateral triangle. All sides congruent. I would take good notes on this. Okay, isosceles triangle. On this question in the past, a lot of you missed it because you put 2 sides congruent, and that is not correct. An isosceles triangle can also be an equilateral triangle because an isosceles triangle has at least 2 congruent sides. Alright? At least. Could be 3. Scalene triangle has no congruent sides. Equiangular has all angles congruent. A right triangle has 1 right angle. Okay? An acute triangle has 3 acute angles. And then an obtuse triangle has 1 obtuse angle. Okay? 1 obtuse angle. Now, students, I'm going to pause. I know I went fast. Well, I'm going to move on actually, but if you need to pause the video, then pause it. That's fine. And go ahead and copy all this down, okay? But again, you don't have to memorize these. I'm not going to put these on your test like fill in the blanks, but you need to be very familiar with these and know what they mean, okay? Alright, moving on. We're going to find the measure of angle 1. Now, what we're practicing here is this. Go ahead and copy this down, please. What we're practicing is this. We're realizing, first of all, what we're reviewing here is, first of all, a straight line, all with a line coming off of it. Always means this angle here and this angle here will be supplementary. They'll add up to 180, okay? So if this angle here is 40, our goal is to find the measure of angle 1. We really can't find the measure of angle 1 until we know what this angle here is, right here. And we can't know what that angle is until we find what x is. But look right here, this angle here is 40. That means this other angle here has to be 140. They have to add up to 180, okay? So I can solve for x very quickly by saying 3x equals 140, okay? Now bring the 10 over, make it negative. 3x equals 130. Now students, next we're going to divide both sides by 3. So we have 130 divided by 3, and you're going to get 43 1/3. Now to be honest with you, I really don't mind you rounding that to make it a little easier. That's not a big deal to me. So look students, now that I know what x equals, look guys, don't lose sight of the trees for the forest. My goal is to find the measure of angle 1. And if I can find the measure of angle 1, because I know that this angle and this angle and this angle all have to add up to 180. If I just knew what this angle right here was, right here, then I could find the measure of angle 1. Well, I do know what this angle is because now I know what x is. So where this x is right here, I can put 43.3 plus 10, okay? Let me grab my calculator. So 2 times 43.3 plus 10 is going to give you 96.6. So I do know this angle right here. It's 96.6. So if I take 96.6 plus 40 and subtract that from 180, I'm going to get 43.4. So this angle right here should be, I'm going to draw an arrow to it, 43.4 degrees. And I know that because if I take 43.4 plus 40 plus 96.6, I will get 180. So what we're reviewing here is the angles inside of a triangle add up to 180. And also, whenever you have a straight line and one line coming off of it, those two angles will be supplementary. Okay, moving on, find the value of x. Now students, in a lot of problems this year, listen to me, I have given you extra information that you don't need. I do that so that you can really show me that you know what you're talking about. We do not need all 3 of these. We just need 2 of these. Now look guys, see how this angle here is congruent to this angle here? Well, we learned that whenever 2 angles inside of a triangle are congruent, their opposite sides are congruent. So go across to this side and go across to this side. If these 2 angles are congruent, their opposite sides are congruent. So if this side here is congruent to this side here, then I can set up a really nice algebra equation. X plus 11 equals 2x plus 8, and then solve. Bring this x over here and make it a negative x. Bring this 8 over here and make it a negative 8. Okay, so this is gone, and this is gone. So I have 11 minus 8, that's 3. And I have 2x minus x, which is x. So there, I found the value of x. It's 3. Okay, this one here, students, we're going to solve for x and y. Now what I want you to realize here is I want to review the property that says when you have an equilateral triangle, that means all 3 sides are congruent. When you have an equilateral triangle, then you also have an equiangular triangle. So even though there's no numbers for the angles in this entire triangle, you can still solve for x and y, because if I have an equilateral triangle, then I also have an equiangular triangle. So all of these add up to 60, okay? Now, see how I have a straight line here with a line coming off of it? That means this angle here and this angle here are supplementary. So if the one angle is 60, then this angle right here has to be what? 120 degrees. Now please watch this carefully, students. See how this, look at this triangle I have right here. I'm going to go ahead and get rid of something here to help you guys see watch this carefully, students. Look. Notice how I have a triangle here with this side here congruent to this side here. Well, now we're learning that when two sides of a triangle are congruent, their opposite angles are congruent. So this angle here, x, has to be congruent to this angle here. Now think about that for a second, guys. If this angle is 120, 180 minus 120 is 60. So these two angles together, x and y, have to add up to 60. Okay? And the only way they can do that is if y is 30 and x is 30. Okay? Because they're equal. Alright? Angle y and angle x are equal. So 30 plus 120 gives you 180. Alright, moving on to number 19. Now please make note of this in your notes. Students, please make note of this in your notes. These are the 5 ways that we have learned to prove that triangles are congruent. Side, 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 angle, 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 side, and hypotenuse leg. So very quickly, now I'm going to go a little fast. So all that you have to do is ask your supervising teacher to pause the video. Okay, that's all that you need to do. But listen, I want you to copy this in your notes and then answer the question, how can I prove which one of these methods would I use to prove that these two triangles are congruent? Well, guys, it's obvious. I have 3 sides in one triangle congruent to 3 sides over here. So based on this side postulate, I can state that these two triangles are congruent. Okay? Alright, not too difficult. Let's continue on. Let's see what we have next here, guys. Okay, this here. Okay, now notice what I have, students. Look. I have a side, an angle, and a side congruent to a side, an angle, and a side. Okay? So, I can definitely state that these two triangles are congruent. And which method would I use? The side angle side method, guys, is right there in front of you. Side angle side congruent to side angle side. Okay, alright, let's continue on to okay, guys, I'm sorry, my computer totally froze up, and so I was able to save the video, thankfully. Thank the Lord for that. But I forget where I was here. I had to close the program and reopen it. But I believe I was saying to you that we have a side angle side congruent to side angle side. So yes, these two triangles are congruent. By what reason? Side angle side. Okay. All right. Moving on to the next problem. Okay, now, students, my advice to you, I would split these two triangles up. I really would. I think it's easier to see when you do that. So one triangle looks like this. The other triangle looks like this. Alright, now, this angle here has 2 marks. This angle here has 2 marks. This angle here has 1 mark right here. That'd be that angle. This angle up here has 1 mark. So, a mark. So, really, here's what we have now. Do you see, students, how these two triangles share this side right here? They share the same side. So that means this side here is the exact same side as this side here. So those two sides have to be congruent. So put a mark here and a mark here. So look what you have. You have angle, side, angle, congruent to angle, side, angle. So yes, these two triangles are congruent by angle, side, angle. Okay? Alright, now, one more of these, we're almost done, then one more problem, and we're finished, okay? So hang in there. Now, same thing with this problem here. It might help. It might help for you to split it up, okay? So we have one triangle like this, and one triangle like this. Now, students, notice that I have this angle here congruent to this angle here. Also notice, students, that I have a right triangle here. Okay? So I have a right angle here. right angle here too. Okay, even though it's not marked here, I know that's a right angle. Now, notice they share this side. So this side here is the same as this side here. Okay, so I know I can say this side is congruent to this side. So I have angle, angle side, congruent to angle, angle side. So yes, these two triangles are congruent. By what reason? Angle, 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 side. Okay. Alright, last problem, we're finally done. And this problem here is going to help us remember that when you have an exterior angle, it's equal to the sum of the two remote interior angles. And you'll see that in just a second, okay? So here we go. And actually, to be honest with you, I think I'm wrong on that. I don't think you'll have to use that at all. But first of all, let's take a look at this triangle right here, okay? This triangle here. Notice in that triangle there, we have this side congruent to this side, which means the opposite angles are congruent, okay? So if this angle here is 25, then this angle here has to be what? 25. Now, add 25 plus 25 together, you get 50. So this angle here, x, has to be 130. Okay, 130 plus 25, and 25 is 180. Now look what we have next, students. We have a straight line with a line coming off of it. So this angle here and this angle here are supplementary. They add up to 180. So if this angle here is 130, then y would have to be 50, because 130 plus 50 is 180. Okay, now we're almost done. So I'm going to go ahead and put 50 right here. Okay, now let's see here, put a 50 here. Okay, this is a right angle. Okay, that's a right angle. So if this is 25 degrees here, then this over here has to be 65 degrees also. Okay, because they have to add up to 90. And now look what I have. I have this triangle here. I know two angles, and I'm missing the third. So not too bad. So I'm going to say I have 65 here plus 50 here will give me 115. Okay, this angle here plus this angle here would give me 115. And then subtract that from 180, and you will get 165 degrees. Okay, 165 degrees. Okay, let's continue on. I think actually that's it for the review. Yeah, that's it. So students, I hope you've been able to push yourself, stay awake, and take really good notes. Only one more day of this, then your exam, and you'll be off for Christmas break, okay? If I can answer any questions for you, don't hesitate to call or email.